It's like what I told you guys, the exam, sorry, if you want to prepare for, I suggest don't use your tutorial questions. I don't know whether your tutorial is universal or is it just your teacher. Is it, yeah, so you're referring to the whole worksheet, right? Yeah, okay, let's not use that. If you have that teacher, I don't know who this guy is. Yeah, I suggest using either your school tutorial or our tutorial. I think it's a lot better. Like I told you guys, try to focus on the level 1 questions. Level up questions, never mind. That one don't know how to do is okay. Because we're not at the exam period yet. Okay, later you want to show me more of your whatever question you can show me later. Okay, but for today we are gonna start on Halogen's tutorial basically. We still have a bit of content that we haven't finished yet. Once we finish that content, which is like 2 segments, and then we'll start on tutorial questions. Okay, Ken? So tutorial questions are easy to moderate today. Not too difficult like the one that I sent in the group. That one honestly a little bit challenging. Okay, I mean it's doable, but still challenging especially for you guys. Yeah. Okay, so all for the tutorial. Okay, for everything up. Okay, come. I'm gonna finish up the content first very quickly. Okay, so last lesson, or pretty much let's summarize what we have done so far. First lesson, we discussed basically reaction and synthesis. Okay, this is what you're preparing right now in your cheat sheet. Okay, bare minimum is your content that must be the cheat sheet. Okay, so that one, of course, when I check, I just see it's there, can already. Okay, but what's more important are all the question types now. Like for example, for this first lesson, right, reaction synthesis is question 4 in your tutorial. You need to know some of those questions and you put it inside the cheat sheet, for example. Maybe not everything, maybe 1 or 2. Okay, the second lesson, which was last week, we discussed a core concept of nucleosub in terms of SN1 and SN2. Okay, a lot of areas to focus on here. A lot of different factors, like each SN1, SN2 has like 5 different properties. Okay, we will not recap all of that. Okay, later questions we'll recap. Okay, for today's lesson, we're going to touch on halogenal elites. And we're going to touch on distinguishing tests. And that's pretty much it. Very, very simple segment today. Okay, it is the second segment, right? It takes up the most time. All right, so you can turn over to page 31. Right. Okay, so we have discussed halogenal alkanes all the while. Okay, but now we're going to discuss your halogens bonded directly onto benzene. So something like this, that's a halogenal theory. Okay, so you look at this molecule alone, at face value, how many things are there, right? Okay, there is clearly a fat benzene, and there's a halogen. Now, based on our current knowledge, okay, can you all remember benzene undergoes what reaction? The ring. There's only one reaction you can undergo. Electrophilic substitution. Yeah, okay, so that's number 1. Okay, so number 2 is that you have a halogen, and based on the last 2 lessons, we know that halogen undergoes nucleosub, either SN1 or SN2, doesn't really matter here. Okay, but we are going to find out soon that it can undergo electrosub, but it does not undergo nucleosub on the halogen. Now, there's a reason for this. Okay, let's just follow the train of thought. You cannot undergo nucleosub. What does that imply about this bond? Can it be broken? No, right? Okay, because if you look at the nucleosub, you change it to something else like OH, you need to break that bond first, right? So if you can't undergo nucleosub, that means you cannot break the CX bond on a benzene ring. Now, if you can't break that bond, what does that imply about the bond? It's very, very strong. Yes. Okay, so the CX bond is very strong. Now, when a bond is very strong, we're going to answer why. Why is it that this CX bond on the benzene, right? It's a lot stronger than normal CX bond. That is the special part of this topic. Okay, of this portion. Okay, so we're going to answer that last part. And the last part will help us to answer why nucleosub is not possible. Basically, this halogen is going to get stuck here forever because that bond is very, very strong. Okay? So to explain that, okay, there are 2 reasons. Okay, the main reason we're going to discuss today is the electronic factor. Okay, the name itself doesn't mean anything. Okay, what I want you guys to do is turn over to the next page. I think there's a box, right? Okay, we're going to draw a diagram in this box first. Okay, if you guys revise your areas, right? Okay, your concept over here is not that new. Okay, not that foreign. Okay, so first of all, I want you all to talk about benzene. Okay, let's recap a few things here because it's tested next week, right? Okay, can you tell me, right? Each carbon in benzene is what hybridization? S2. Okay, good. So if each carbon is sp2 hybridized, that means each carbon also has a what orbital? Okay, unhybridized p orbital. Okay, a p orbital is just by itself, by its lonesome, so it's not hybridized, right? Hybridized means you must combine, and that means you have something like this. Okay, take note of the terms. Okay, so if every carbon has a p orbital, what can all these p orbitals do? Okay, so imagine this diagram. Okay, each one of them has a p orbital all side by side, and they will end up overlapping. Okay, so if all of them have a p orbital, then it's a continuous p orbital overlap, correct? The keyword here being continuous because it is literally in its cycle, right? Okay, this is a recap of Aries, right? So if all the p orbitals overlap, this allows what to happen. Okay, so now you can imagine, right? All of them are holding hands with one another in a nice little circle, a cute little circle here. Okay, they are all connected. So now what can happen? What can delocalize? Okay, the pi electrons in benzene can end up delocalizing, and we call this a very nice, what's the nice phrase here? A delocalized pi electron cloud. Okay, so that's like the basis of benzene rings. Okay, so clearly, delocalized pi electron cloud causes the benzene to have a lot of different properties. The main one being benzene is a very one compound, very stable compound. Yeah, and it's all because of the delocalized pi electron cloud. Okay, so right here is just a recap of Aries. But now I'm just going to add one single halogen onto that Aries. Okay, so let me plug one Cl over here for instance. Can I ask you guys, does chlorine have a p orbital? Yes, okay, like 1s2, 2s2, 2p6. Yeah, okay, so it has a p orbital. Let me just draw it right here. And guys, what would this p orbital do? Okay, fair enough. Okay, you can see this p orbital is right beside the benzene's six people here just happily connected to each other, right? So what would this p orbital do? Okay, you can also connect with them, right? Okay, because it's beside the benzene, directly bonded to the benzene. So what's stopping the p orbital from overlapping? Nothing, right? You can just overlap. Now that it's all of them, including this dude, right? What can happen? The Cl contains a lone pair. Any guesses what this lone pair will do? Okay, now that there is a path connecting everyone together, now this lone pair is also free to travel, right? So the lone pair can actually localize into the benzene. Make sense? Okay, so let's get all of that down first. Okay, so this diagram, right, try to draw it in the box, and we're gonna explain. Okay, the box is quite big. Let's just write down some explanation inside. First of all, you need to acknowledge that the p orbital of chlorine overlaps with the pi electron cloud of benzene. Okay, so what's happening here is just a continuation of the explanation that I talked about right here. Okay, the p orbital of chlorine overlaps with the pi electron cloud. He is joining in the 6 carbons, right? And when this happens, when they're all connected, the lone pair of electrons on chlorine can now delocalize into benzene. As you can see, there, draw the arrow inside to showcase the delocalization. Right, so that's all we have learned so far. Okay, we actually learned this in the previous chapter of theories as well. Okay, where the loop can actually just delocalize if there's p orbital overlaps. Okay, can so far. And now we're going to move on to the more important concept of what this leads to. Okay, so copy this down first, nothing new. Okay, the next point is going to be important. So far, any questions? Okay, because this is going to be tested next week. How a benzene is very stable is explained by these points, including this one, by the way. Okay, so all these points over here help to explain the origin of the delocalized pi electron cloud. Another word for this is called resonance. So honestly, right, it's nothing special. This word just means that. Similar ideas. Okay, good. Okay, so you have written until the second point here. Up until now, have we explained why the bond is very strong? Is that related to anything so far? No, right? Okay, we only discussed delocalization. How does that make this particular bond here stronger? So I'm going to introduce this new term here, right, which you have probably seen as well. This will actually result in partial double bond character. Okay, let's just see what this means first. I don't want you to just take this forwards at face value. Okay, so this is the main driving factor for this question. Okay, I can explain this in a very, very simplistic way, right? Okay, so see whether this makes sense to you guys also. Okay, again, sometimes right, we need to think in a very shortcut manner to make things easier. Can I ask you, this single bond, is a single bond or is it a double? Okay, single, clearly, right? Okay, from right now, it is clearly a single bond. However, guys, a single bond, okay, let's just look at okay, it's made out of just one sigma bond, right? Finish. Okay, how does a double bond look like? It's made out of what and what? One sigma and one pi. Okay, I'm more focused on the pi, guys. How does a pi bond form in the first place? Okay, a side overlap of what kind of orbitals? P orbitals. Good. Okay, so let me erase that. Okay, so this is how the diagram should look like, right? If you were to form a pi bond. Okay, I don't care about the sigma, just look at the pi and see that. Now, do you notice, right, that this is a single bond, but yet it has that p orbital overlap that you see right here. So can you see, right, it is technically having a little bit of double bond genes inside. Okay, so let me explain. This is a single bond, but yet there is a p orbital overlap. So technically speaking, it has some properties of a double bond. Make sense? Okay, so it's like your mom is a single bond, your dad is a double bond, and then your child is a mixture of both properties. In other words, we call that partially a double bond. Can you see that? Is it actually a double bond? No, right? So it's only partially a double bond. To give you guys an alternative explanation, let me show you guys this new concept. A single bond has this thing called bond order, and the bond order of a single bond is just one. Okay, some of you guys might prefer this explanation. Okay, a double bond, you can already guess it. You want to guess what a bond order is? 2 lah, right? Okay, so imagine this. This one is a mixture of a single bond and a double bond. So what do you want? Can you guess the bond order of this guy here? It takes genes from both a single bond and a double bond. Okay, it's 1.5. Yeah, actually, yeah. Right. Okay, the bond order of this is 1.5. Okay, meaning to say it is stronger than a single bond, but not as strong as a double bond. So it's called partially a double bond. Make sense? So that's why, right, you can see it is already stronger than a single bond, which already makes it very hard to break. That's why it doesn't undergo nucleosub. So to expand on this idea, you cannot just stop your answer here. Partial double bond character strengthens the CX bond, making it hard to break. Okay, so as I have done over here, I have linked back to the core idea that I'm trying to discuss. Why can't this undergo nucleosub? It's because you can't break that shit. And you can't break it because it's very strong. So you're supposed to link to why it is strong. It's because this bond is a 1.5 bond. You can think of it that way. This is personally my favorite way of looking at this. It has both properties of a single and a double bond. So it's kind of in the middle. Does that make sense? Okay, so what you need to do here, guys, this electronic factor, right, is must to write all this. In other words, you don't really have to think about application, just write down this explanation. Any questions? For main explanation here. Okay, there is another way of explaining this, but it's not as important, so I'm not really going to discuss. Okay, bond order, no need, it's not tested in your syllabus, but I don't think it's very difficult to see the link, right? Because bond order is just a number of bonds, 1, 2, and then this 1.5. Okay, it's just a number assigned to it. So if you guys are a bit more numerically inclined, right, okay, this would be a bit better. You're good. Okay, again, content today is not much. Okay, so let's go on very quickly. The second idea is steric factor. I don't need to explain this all that much. It's already written in the notes. In fact, this one doesn't have a very, very strict way of answering. Like you guys can just kind of smoke out the answer yourself. Okay, let me just go over the idea. Okay, guys, when you think of steering, what should you think of? Like, what's the idea over here? Steering. You think of steering hindrance and all that. Okay, it's all about space, right? Steering hindrance means that it's very congested, then you don't have space, right? Okay, same idea over here. Okay, we can use the steering factor, the space factor, to argue that this guy cannot break. Okay, why? Now, this is undergoing nucleosub, right? Let me just put a nucleophile over here. And this nucleophile has to somehow attack this carbon to replace it, right? Now, nucleophiles reach or pull? Reach. Okay, as you're approaching this guy over here, right? Is there something else that's reach as well? The big fat benzene ring is also rich because of the delocalized pi electron cloud. So what's going to happen? You have rich and rich. What's going to happen? It's just going to repel and you can't even approach. So that's the idea of steric factor. Okay, it is not it's not as significant as this. Okay, that's why, right, guys, in exam, if they were to ask you to write a reason, which one should you write? They never specify which reason. You can always write the first one. Steric factor is legit. If you die, forget about this, right? Which you shouldn't. Okay, die in the exam, let's say you panic, you forget about this, right? Then at least write something with the steric factor. Okay, don't leave it blank because this question is only one answer, or sometimes two answers. Okay.
Why?
Okay, why can't this guy undergo nucleosub? Something along those lines. Okay, of course, it doesn't have to be word for word, right? Okay, so it's to justify why this is unreactive. They can use the word unreactive also. Okay, a more broad-based word, but you should know what they're referring to. This guy can't break. Okay, so you can maybe take down. Okay, the example question would be, why is this compound unreactive? Again, it is a very general term. Again, it can come out in many ways, right, to phrase that one little question. So it really depends. Okay, can so far? We are pretty much done with like the core of today already. Yeah. Okay, the notes for steric factor has used some very nice words like inter-electronic repulsion, blah blah blah. Very nice. Okay, very bulky benzene ring, high steric hindrance. You see, it's not very important lah. Okay, you all can kind of give the answer yourself. All good? Can I? All right, okay, you can turn over to page 33. I won't be discussing this all that much, okay, because it's about the electron sub. Okay, you take a look at the board here, right? This compound cannot undergo nucleosub. Then what can it do? You can undergo electrosub. Why? Because there's a benzene ring. So electrosub is just the same as whatever we discussed before. Okay, but the difference is, let's talk about this for a bit because you all tested this next week. The difference is we have a halogen, for example, Cl, correct? Okay, what effect does Cl have on the benzene ring? Okay, of course, a normal benzene is just normal, right? But now that you have a substituent Cl, what effect does it have? And when I mean effect, I mean donating or withdrawing, right? So what's the effect here? Can't remember what you do. Okay, your data booklet has the answer. Okay, for Cl, it is considered, okay, the data booklet writes deactivating. So what does this mean? Okay, it is electron withdrawing up. And they also talk about your directing effects. Okay, so I mentioned this in yesterday's WhatsApp message. Okay, so other than reactivity, it also affects the directing effect. Cl is 2,4 directing. Don't need to memorize all this, is in the data. So let me run through this very quickly. An electron withdrawing substituent literally tries to steal electrons from benzene, right? So does benzene become richer or less rich? Okay, can I use the word poorer? The benzene becomes poorer. Why cannot? Okay, it's a rich person. Okay, you can't make him poor, right? Okay, so it just becomes less electron rich, which means what? More reactive or less reactive? Okay, definitely less reactive, right? Okay, something that's richer will react faster. Okay, something less rich will definitely react slower. Okay, so that's one of the ways they can ask you on this. Yeah, okay, so short little recap is right here. All good? Okay, for the word less reactive, just going to highlight in the notes. You can't just write less reactive. Okay, for the second point, just write, highlight the words less susceptible to electrophilic effect. It's a fancier way of writing this. Okay, again, just follow along. Yeah, okay, no choice. Okay, again, such explanations, right? You should have this in your head first, and then you just try to test yourself right on the cheat sheet. Okay, again, you don't need to show me the cheat sheet by today. If you want, you can. Okay, but if not, you can always show me another day. Yeah. Okay, over. Right, we're just gonna move on to the final part of the whole tree. Yes. The Cl. Talking about the Cl here. The Cl group is electron withdrawing. So if it draws electrons from benzene, deactivating just means electron withdrawing. These are the same thing. Your data booklet prints deactivating. Okay, so we need to translate that to terms that we're more used to. Okay, over. Okay, can so this segment here, finish. The main part of this segment is just this. Meaning to say, guys, when you study, right, you can only think of, yeah, I'm studying this part, the electronic factor, and that's it for this segment. Okay, if not, we'll move on to the last part. Okay, so as we discussed today, we're going to talk about distinguishing tests. How do we distinguish different types of halogens? Okay, you've probably seen this before, but I want to explain the rationale behind the reaction, and then we can just conclude that. Right, so as for distinguishing tests, right, there are 3 steps in our reagents and conditions. But what are these 3 steps? Okay, so you all see the box at the bottom of page 34. I need you all to copy down these 3 steps again, because we're going to explain every step's rationale. Now, what's the point of this? Of course, you're not going to test the rationale, but it's to help you all remember better. You know the purpose at least. Don't just blindly memorize. Okay, anyways, imagine this. I have a halogenal, chloroalkane, chloroalkane, bromoalkane, and iodoalkane. How do I distinguish different types of halogens? Okay, there's only one answer. You need these 3 steps in your answer. So segregate it into 3 steps. NaOH heat. Okay, sometimes you see the word excess HNO3. And finally, AgNO3. Okay, we're gonna just copy these 3 down first, and we're gonna ask ourselves what is the rationale behind these 3 things. Okay, based on your reagents and conditions, right, guys? Can you all remember what NaOH heat does to a halogenal alkane? Okay, what reaction is this? Or what does it do? Okay, so if we have a Cl or any halogen, you react it with NaOH and heat. What do you get? Okay, let me just write the full equation. Okay. So I will add a OH minus, and then it will just substitute, right? Okay, you just swap it out. This is your standard nucleosub reaction. Okay, so I heat it to get this. Okay, so what's the purpose of doing this reaction? Okay, so look at the products of this reaction. Is it to get an alcohol? Not sure. Perhaps I can direct you all to the last step here. What does AgNO3 aim to do? Whenever you all see AgNO3, in particular Ag is to react with what? Okay, is to react with which ion? Okay, so next time you see AgNO3, it's always to get or to precipitate AgX. If there's Cl, there's AgCl, AgBr, AgI. Okay, so you're adding AgNO3 most of the time, right, is to get a AgX precipitate. All good? Right, so can you see what's the purpose of the first step? My starting 3 reagents are like this. Now, in order to form AgX, I need to have Ag plus and X minus, correct? I mean, that's the ions one, right? So can you tell me what's the purpose of that first step? What am I actually interested in that thing? Okay, you see, right? If I don't have the first step, I just put AgNO3 and I form my precipitates. Okay? Okay, no, right? Okay, my precipitate requires X minus. X minus is produced in the first step only after you have undergone the substitution. In other words, the purpose of this first step is to liberate the X minus ion so that you can use that later for HX. Correct? Yeah, okay, so that's quite simple, just the first step there. Now I could have just added the third step and I could have just gotten this done and over with. Agree? So the most important thing is actually the second step. They have tested this, I think, a few times before. Okay, they will ask you what's the purpose of adding HNO3. Okay, before we get to that, does anyone not understand step 1 and step 3? And right, okay, I could have just added step 1 and then step 3, but now I need to take a look at step 2. Okay, to answer such questions, right, we need to ask ourselves, what happens when you don't add this? Okay, so if you don't add HNO3, that means what? First ask yourself, guys, again, HNO3 is supposed to react with who? In context of these 3 steps. What is it supposed to? Okay, it's supposed to react with NaOH, right? Because NaOH is a base. This guy is an acid. So you're aiming to add the second step to get rid of the base, right? You can see that. Okay, that for some reason, okay, that's what we're trying to do. If we don't add HNO3, there will be unreacted NaOH, correct? So imagine your solution over there still has NaOH swimming inside. What's the danger of NaOH? Okay. So if there's NaOH and you add Ag, silver, okay, this is what's going to happen. AgOH, brown precipitate will form. Again, I'm still not at the important part yet. I'm just telling you guys what happens if you don't add HNO3. If you don't add an acid, there'll still be base, and the base will react Ag to form AgOH. Okay, just form lah, right? What's the big deal? Okay, you must always ask yourself, what's the big deal here? That we have to get rid of the base. Guys, we have to get rid of the base so that we can not have this precipitate. Can you all see, right? What's the problem with this being formed? Can someone tell me? The whole thing is a distinguishing test. A distinguishing test relies on your observations, right? Your eyes, right? Okay, you need to use your eyes to literally distinguish. So what's the problem, right, with forming AgOH brown precipitate? It will not say you cannot see, right? It will actually just ruin the whole thing. Does that make sense? Okay, you see, AgCl will give me okay, this Cl will give me AgCl, this one will give me AgBr, this will give me AgI. Agree? Okay, so they all have their own colors, which you also need to memorize. White, cream, and yellow. Okay, the color just memorize, all right? Now, when you see one of these three colors, it tells you what halogen is inside your test tube. Agree? But now that there's a brown color, what would you think to yourself? You would think to yourself that there is a halogen inside, right? But I could have just had a random ass molecule, like for example, this alkane. Guys, if I were to put this alkane inside, I will still get a brown precipitate. What will you tell yourself? You would tell yourself that there's a halogen inside, agree? Okay, and that right there is not what we want. Okay, so I want you to write this down. The second step is to prevent a false positive test. I'm sure you all know what false positive is. Okay. The result of the test tells you that there's a halogen. But then actually, right, there's no halogen. That's what a false positive is. So I need you guys to just, in the exam, if they ask for this, right, just write this down. Okay, that is like the best way to express your explanation for this truth. All good? Can Okay, so once again, just memorize the reagents and conditions, reagents and conditions, yes, and memorize the colors, and you're done with this segment already. All good. And we're done with the notes. Okay, all good. Any questions here?
Wait, what?
Yes. Okay.
What do you say?
Okay, imagine, right, your unknown solution has a halogen. You expect to see one of these three colors, or any color in fact, right? But imagine you have this in your test tube. You wouldn't know at the start, right? It's a random alkane. There's no halogen basically. Okay, if there's no halogen inside, and then suddenly you still do this experiment without the second step, you suddenly see a brown precipitate. Now that brown color, right, will just tell you that, oh, there's a halogen inside, right? But is there really a halogen inside? So it's a false positive. It doesn't have but that. Okay, there isn't a halogen, but the results tell you that it's like you don't have COVID, right? Then the stupid kid tell you that you have COVID. That's a false positive. Yeah, the brown's not the color, but you don't want any ambiguity because you all have to understand, right? In real life, these colors, right, are not perfectly white, cream, or yellow. There's a lot of contamination. Like if you do it in the lab, right, sometimes your cream will look a bit dark. Then you might be mistaken for brown. To avoid to remove any sort of possible error, right? You have to get rid of any other types of precipitates. So I know it's not one of the colors you expect, okay, but you just want to remove the error. Okay, Ken? All right, all good. Okay, the page 35 is just, yeah, it's just another like way of doing this as an alternative. Okay, y'all can just take note of that. Okay, I don't have to go through page 36 onwards because that's like freaking ozone and the environment. Who cares, right? The earth is gonna die anyway. Okay, screw that. Okay, they're not gonna test it anyway. Okay, so I want you guys to turn straight to the tutorial. Okay, we don't have much time for that. Alright, okay, so that was a bit more free fall. Okay, what I want you all to do now. Can you all turn to question 5. We start with level 1 first. Again, that's your focus. Okay, level 1, question 5. Okay, each of these question is like really short. Okay. Alright, if anyone needs paper, you can just take it from sites. I'll give you. Very soon. And like anytime you feel tired, just go to the toilet and like splash yourself with water or something. Yeah. Another tip is just like gulp down 500 ml of water. I think I've told you all before. It really works. Yeah. Yeah, fine. Okay, read through the 3 lines, and I just need you all to draw. Okay, of course, draw the compounds in skeletal lah. Okay, make it a habit from now on. Okay, I don't have to say already. Like if you see a structure, right, you can't visualize that structure from here. So draw a skeletal formula. We'll discuss this in a minute. I just need you all to draw the skeletal formula. Okay, so these are the 2 species. Okay, so one of them is reactive, the other is okay, you're supposed to tell me why. Okay, why is it that the guy on the right, is not reactive? Okay, any possible answers? Okay, the word unreactive is again very vague, right? Okay, it's like it just doesn't react. But what in terms of what? Okay, guys, it doesn't react in what reaction? Okay, halogen supposed to react with what? Like it's supposed to undergo nucleosub, right? Okay, if it's not reactive, that means it doesn't undergo nucleosub. But why? Again, what's the logic that we used just now? Okay, unreactive means cannot nucleosub. You cannot nucleosub means what?
Partial double bond pair.
Okay, we're skipping a lot of steps over there. Okay, so you cannot undergo nucleosub because this bond cannot break. You cannot break this because it's very strong. Okay, so that's the same logic that we're going to use here. It's very strong because I'm sure we have just gone through that explanation. Okay, but why? Just now I applied it onto a benzene. How come here got the same explanation? Okay, what's so special about the double bond? Come, let's build up our answer. Just now there's a benzene, yes. Okay, so good. Okay, look at the pi bond here. What do they have? A p orbital each, right? Okay, that's what each carbon has. So these guys will overlap to form what?
Neutralized by electrons.
Okay, but again, first one they form a pi bond, right? Okay, so okay, then what's so special? What's next?
Partial double bond pair.
Okay, but why? You have a skipping steps, guys. You must slowly work our way there. Yeah, but why first? What does bromine have? Okay, we are still skipping all the time. What does bromine have in the first place? A p orbital, exactly. You guys know steps. Alright, the p orbital does what? No, p orbital cannot deal, guys. Orbital just folds. Yes. Guys, we open rest with the rest, right? It's right beside you overlap first. Now that all 3 of them are one, what will happen now? Oh, holding. What delocalizes? The lone pair that's on the bromine that will delocalize into the pi electron clouds. Like you have mentioned. Yes, everything out. Okay, guys, go write it down. I'm not writing it down for you. Okay, try to write it down yourself. Okay, cannot anyhow jump steps, if not you miss out a lot of people. It always start from what happened first, then next. That will be actually better. Okay, but no need, like, you can just tell me that it's pure. Yeah, but yes, yeah.
The p orbital of the bromine overlaps with the orbital.
Yeah, okay, that works. Yeah. Let's start with an easy question. If p orbital of bromine overlaps with the p orbitals of double bond, that works. You can say overlap with the pi electron part of the double bond, also can. Okay, then this will allow the lone pair of electrons of bromine to delocalize. Now the act of this delocalization then results in the partial double bond character, where the bond is not a single nor a double bond, it's somewhere in between, right? Okay, so we went all the way to partial double bond, but is that the end? Okay, there's more things to write about, right? What are we supposed to link to? Okay, good. Okay, so partial double bond character only does one thing, to make the bond stronger. So which strengthens it, making it hard to break. Okay, finish. So guys, whenever you see a halogen bonded directly to a double bond or bonded directly to a benzene, in both cases, they recycle the same explanation. Okay? So now we just keep an eye out for these two compounds. Any bromine attached like this, leave it alone. Like it doesn't move, it's just there. It doesn't react, it doesn't do anything, unreactive. Right? Can Okay, guys, they asked for a second explanation. Let's not spend time writing it now. Okay, can you tell me what the second explanation is about? Steric hindrance, yes, that's it. Okay, you can make a note there. You can write it down yourself in your own time. I'll move on to other questions. Okay, because this double bond here is also rich, right? So any nucleophile that approaches will still get repelled. It may not be as bulky as the benzene ring, but it does have repulsion because it is a rich double bond. Nucleophiles are also rich. They will eventually repel each other, making it very hard to attack the carbon. Okay, can? Again, that one is not my concern. Again, the question asks for two explanations. Okay, you all can write it down yourself. Okay, I want to go straight to the next question really. Okay, so go over the question 6 and you want to try part A. Distinguishing test. If possible, try to come up with multiple answers. Okay, come up with at least one first, right? Yes, correct. Okay, right. The moment you see the functional group, you think of its associated reactants, which you should know because again the next week is tested, and you should have a list of it already. You don't need to recall everything to go through everything. At least remember one for each. Okay, eliminated is a possible reaction, but like you don't see anything. Yeah. No, cannot. Okay, elimination works for which one? The one with CL, right? Okay, you can. Does it work for alkene? No. Okay, but you still need to make sure that you can see something. Elimination, nothing, no observations. Okay, that's a possible answer. Okay. See, everything is coming back already. Yeah, multiple answers here. Yeah, that right, that's not the only answer. Okay, maybe go through this step by step. Hey guys, there are two functional groups, correct? It is your choice to choose which one you want to have a positive observation. Let's just say I want a positive observation for CL. Guys, what reaction should I use? Yeah, the one that's literally what we went through. Yes. If you want this one, right? Okay, let me. Okay, the everything you all can write yourself, but I'm only focused on this part here. Remember the three things that we went through just now? You have to add all three inside. NaOH heat, HNO3, AgNO3. So what are the observations for the first one?
You get white.
Yes, okay. For the first one, you get a white PPT of AgCl. Okay, specifies identity also. Then for this guy, do you see anything? No. Okay, because for this reagent and condition, you only want to distinguish anything with a halogen inside. This one has no halogen, don't see anything. Can see that? Again, halogenous alkanes only have one distinguishing test, which is what we went through earlier. Okay, again, don't write in this format. Must write in the format of the reagents and conditions first, the observations for this guy, and then the observations for this guy. Okay. Never mind, for now, you can just jot down. Okay, you can tidy up yourself in your own time. Okay, what I want to go through, right, are the possible answers for the second structure instead. If you were to choose the second structure to distinguish, any answers that you all have? Any suggestions? Okay, if you use the same test, then I'm still distinguishing the first one. No, I want to distinguish this one. Meaning I want a positive observation for this guy. Currently, this is a negative observation if you use that. Okay, I can use bromine, good. Okay, because what reaction is that called? Okay, electrophilic addition. I can use bromine in the liquid state, or I can use bromine in the aqueous state. The color will be a bit different. Again, I don't really care. Okay, all the colors for halogens are in the data booklet.
It's just like just keep one there.
Yeah.
This one observation happen.
Correct.
The other one observation happen.
Correct. That's it.
Yeah.
I'm going through all possible answers.
Yeah.
Okay, so it depends on what you want to choose. That's why I say, guys, distinguishing test is not difficult because if you study, you'll know more answers. Okay, other than electrophilic addition, any other answers for this guy? Okay, oxidation. Either mild or strong actually works. So let me separate them into two. Mild oxidation and oxidative pH, which is strong oxidation. Okay, mild oxidized, remember, turns a double bond into a diol. Yes, OH and OH. Okay, so if there's an observation here for mild oxidation, what will you see? What's the observation? Oxidation requires what reagent? KMnO4. So what happens to that? K will decolorize. So that's pretty much it for the first one. Purple KMnO4 decolorizes. Okay, how about strong oxidation? Okay, so strong oxidation also uses KMnO4. So what happens? Okay, first of all, does purple KMnO4 decolorize? Yes, okay, as long as there's a reaction, it will still decolorize. But what else? So you just mentioned. Okay, why is there effervescence? Okay, why is that the case? Okay, good. Okay, good. You recognize this right here is a terminal alkene. Must include all possible observations, and those are the two. So depending on what you choose, if you choose oxidative cleavage, your observations are a little bit more. But if you see a halogen, you can just go straight to whatever you just learned. Also can. Right. So many possible answers. Just choose one in the exam. That's it. Anything that pops in your head, just write already. That's 2 marks. Yeah, one of the easiest questions to do. Can see that? Okay, do part B because part B is really as easier, as easy or even easier. Okay, so take a look. Okay, for part B, just express in the proper manner. So when I mean proper manner, I mean like the reagents and conditions, you state, then you draw the first and the second compound. Yeah, okay, this is the format. Okay, over. What's the answer over here? Okay, at this point, you see the rate, because someone tell me the reagents and conditions is for is basically this, right? Okay, it's this. Okay, because you can only distinguish halogens here, right? There's really nothing else you can distinguish. Okay, but I'm concerned about the observations. The first one was the observation. Yes, okay, yellow PPT off. AGI, second one. Yes. Why? Okay, why are there so many halogens here but you only choose this?
That's right. The BR cannot break.
Yes, okay, cannot break. Okay, anything attached directly to benzene stuck there, partial double bond character, it's not gonna budge, right? It's just gonna stay there. You're not gonna get a ion out of it. Finish. Okay, very easy question, huh? Okay, we're gonna move on to level up. Okay, maybe do like 1 or 2, then we take a break. Okay. Or maybe after the next one, you probably want to take a break. Yeah, because a lot of people tend to get very exasperated over the next question. Okay, so guys, let's turn over to level up question 1. It is an MCQ, but quite a notorious one. Came out in your paper actually. Yeah.
It could be. Oh, it's probably is that one. Oh.
I don't know, man. This was my year.
Oh.
Thankfully, I wasn't there. Let me read first. Okay, it's by no means difficult. It's just long and tedious. So just ignore the fact that this is an MCQ lah. Right? Okay, ignore the fact it's an MCQ. And just pretend it's a normal question. Okay, don't care about time constraints or whatever. Okay, read through this question once. Okay, then we'll talk about it together. Okay. Okay, this is a very important question. So you know to highlight this. Okay, so once again, let's pretend this is not an MCQ. We are doing this from the comfort of this room here and not in the exam hall. So just treat this as, let's not skip this. Right. Okay, read through already. Right. Okay, so let me bring you guys through the question one more time. So read through the question with me the second time. They gave you this graph. Okay, so what is this graph first? This graph is after they took one of these four structures, they reacted with sodium hydroxide, then they add AgNO3. Okay, you can see all that first. After you do all that, you can get AgX precipitate. In this case, the AgX is AgCl now because it's all Cl. Okay, so what is this graph trying to say? They use two different concentrations of NaOH, and then somehow you can get two different graphs. First of all, what is NaOH in this question? What's its role? What is it acting as? NaOH is acting as a what? Okay, see what's happening here? You're taking a halogenal alkane and you heat it with aqueous sodium hydroxide. So sodium hydroxide is a nucleophile, exactly. Okay, guys, this is a nucleophile because one of these halogenal alkanes, the chlorines, once you react with NaOH, you will get the Cl minus. This Cl minus, they add AgNO3 to form the AgCl. Can see the flow of events first. Yeah, okay, that's the whole experiment. In the meantime, they actually see, right, it takes time for AgX to form. Eventually, it hits the maximum, right? That means the reaction has completed. Okay, but what's the significance of these two graphs? Okay, so you see, NaOH is a nucleophile. By changing the concentrations of these nucleophiles, the graphs change. Can someone just tell me what's the difference between these two graphs first? The speed, the rate. Can see that first? Okay, that's good. The difference between two graphs is the rate. And the rate is affected by the what in this question? The concept is this, right? This is your independent variable. You change this and somehow the graph also change. So somehow the concentration of the nucleophile affects the rate of reaction. Who is faster, by the way? The solid line or the dotted line? Okay, clearly, okay, go and annotate. The solid line is faster. Solid is faster. Why? How do you all know that? Okay, it's a steeper gradient, right? Okay, so all these things you all should know already. Okay, very good. Okay, we are trying to piece the put everything together first. Okay, so if I use a higher concentration, I get a faster rate. Okay, so a higher concentration of the nucleophile gets a higher rate of reaction. What does this mean? We're trying to determine, okay, all these are halogenal alkanes. Okay, what's this reaction even called when you put NaOH? Okay, this nucleophile, yes, they undergo nucleosub. The whole point is nucleosub, right? Look at this. This is perhaps the main giveaway in this question. The nucleophile affects rate. What kind of reaction is this? What kind of nucleosub does this remind you of? No. Which one? What kind of nucleosub when SN? Alright. So guys, based on this information alone, if it affects the rate of reaction, this means it's an SN2 nucleosub reaction. Meaning to say, let's pause for a while. This question is trying to test you on your knowledge on SN2 properties. Okay, how do you know it's SN2? Because in the SN2 nucleosub, what's the rate equation? Rate equals to? We are K, the rate constant first. Concentration of the halogenal alkane first, and then the nucleophile, right? In SN2 represents two reactants in the rate equation. That's it. Okay, and we are still trying to find out what this structure is, right? Now that we know SN2, can you recall its properties? that can help us perhaps determine what reaction, what structure it is. Okay, I need you all to see the link here. SN2, suddenly they want to determine what structure, what halogenal alkane it is. What is the link here? SN2 is usually what?
One-step reaction.
Okay, that's one of the properties which are not very basic. Okay, it is a one-step reaction, but it's not useful in determining the identity. There's one of these properties that will help us, aid us in determining the identity. What is it? Yes, exactly, guys. Out of all the properties, SN2 nucleoside is generally, I use the word generally again, favored by primary. Again, why do I come to this point? Because I'm trying to determine an unknown halogenal alkane. So why not narrow that down? Instead of just a random halo alkane, it has to be a primary. Okay, like preferably a primary halogenal alkane. And now with this information, does this help me find its identity? Is this good enough to help me find? Oh, why not? Actually, that's pretty damn good, right? From the structures, right, we can actually see who's primary, who's secondary, who's tertiary, correct?
Yeah.
So that is the breakdown of this question. Okay, so before we look at the options, look at it again, guys. From now on, whenever you all see red and halogenal alkenes, it's all tied to one idea. Either it's SN2 or SN1. Yeah, say again. Whenever there's red and halogenal alkenes involved, you must tell me whether it's SN1 or SN2. Now let's look at the options. So far, so good. It's a tough question. I don't expect you guys to be able to do this and break it down like this on your first try. No, not possible. But because it's so much info, go back and definitely look at this again. Don't just throw it at one side because it's a very good question. Okay, option A, is that the answer? Will this be the answer? What's option A? Now we're going by primary, secondary, or tertiary, right? So this is it. Okay, this is secondary. Now guys, secondary undergoes what? Okay, can be either, right? Okay, so maybe don't know yet. Okay, let's move on. Next, B. B is what? Okay, good. B is tertiary, and tertiary is usually undergoes. And then what? Is this answer? High chance no. Next, C. What is it? Primary. Is this correct? No. Why no? Guys, look closely. What do you observe? The halogen is attached directly to a double bond. We already mentioned what happens with this guy. When you see anything attached directly to a double bond or benzene, that is, what's the keyword again? Partial double bond character. Okay, meaning to say, guys, every time you see such scenarios and they ask you to explain why, just remember first partial double bond character. Then all the keywords will come in from there. Okay, but I don't want to just leave it here. Sure, there's partial double bond character. This guy cannot react. Can someone tell me how would the graph look like? How would the graph look like if you choose options? There's no graph. Exactly. Okay, there is no graph. Literally, there is no AGX precipitate. There is zero all the way. Zero. Okay, why? Can the CL break? If the CL cannot break, it means you cannot form one. You can't form AgCl. That's why it's zero now. Okay. So it has to be option D, right? No. Answer A. But let's not look at A first. Okay, let's look at D.
Wait, it's partial double bond character. What is bonded?
Yeah, we are come back here. Okay, it's bonded directly to a double bond. You will get a partial double bond character. Super strong, you cannot break this, it's stuck there.
But if it's bonded just one bond, then it can break.
Let's say it's just like that. Kind of. That's the answer already. This will be the answer.
Okay.
Right? Okay, but there's a double bond here, the CL cannot break. Okay? Okay, but why is it not D, guys? Look at it carefully. Is this a halogenal alkane? What the hell is this, right? Okay, it's not a halogenal alkane. But there is a halogen, right? Okay, to form AgCl, we definitely need a Cl minus. Can someone tell me what is the special thing about D compared to the other three structures? D is an ion. Now, this Cl minus, guys, if I were to add HNO3, okay, I say again, if I add HNO3, I will form AgCl, agree? But how long does it take to form AgCl? Why forever? Ion will just form AgCl, right? So how long does it take? Okay, so this begs another question. This is an instant formation of AgCl. Okay, guys, you have to ask yourself, why does this take time in the first place? Why does this take time?
Because it needs to break.
It needs to break the bond. Guys, CCl bond, is it strong or weak generally?
Strong.
It's rather strong compared to like bromine or iodine, right? So obviously it needs time. So go back to the graph. I need you to annotate this. It takes time to break the CCl bond. Do you need to break a CCl bond here? No. So it's instantly the moment you throw in AgNO3, it will form. So go right now, instant formation as don't need to break CCl bond. Can someone just I want you to also draw how will the graph look like if you chose option D? How will the graph look like? Okay.
And then 10.
No, exactly. Okay, look at the axis. Time is at 0 second, 1 second, 2 second. No. It's just like this.
Oh.
Guys, you know it's at time equals 0, you would maximum already. Does that make sense? Yeah, they could also ask you guys to draw a graph, right? So please draw that inside also. Yeah, giving you more layers than I can possibly give you more expression rate. It cannot be vertical because vertical means what? Like your again, guys, I say already ignore the fact that this is an MCQ. Okay, so this 0 second, 1 minute, 2 minutes, 3 minutes, it's like at the 4th minute, then suddenly it spikes up. That's what it's in track. That's like infinite. Okay, so it's horizontal. So the best answer is option A. Because we did mention that secondary can still undergo SN2. Okay, got it. Again, guys, go back and look at this question again. Try to see whether I don't want you all to just come up with the answer. I want you all to see whether you can break all this down again. Okay, this one. Concentration of nucleophile affects rate. This is SN2. This is the core of the question. All got it? Okay. Okay, just as 1 hour in is 8:30. Let's take a break first. Okay, it can be a 10-minute break. Okay, then later on we'll continue with more questions. Okay, take a break first.
You mean the one that nobody likes? The one that's not society. And your friend is like, there's no way. There's no way. No. The one that the one that nobody likes. Know that we have gone to angry side.
Guys, that's how we have been about this. Okay, so I want you guys to. I actually want to see you guys this. Okay, let's not make it like a passing comment and then let's forget about it. Okay, no. Okay. Okay. Let me tell you how to make it a bit easier for you guys. Okay, so this one right is to really get them fast inside, so we can clock the 15. Okay, but okay, the 15 right? Okay, that's okay. I agree it's by end March because I'll mention it later. Okay, but it continues now. Okay, let's say we haven't hit the 15 by end March, it's fine. Yeah, okay, we will still continue. About that, okay, you can set a quota among yourselves also, 3 each. Okay, I need it. Okay, the first thing you can tell them is I'll be holding trial lessons for them, like right now. So you can just tell them that, oh, my tuition's the just holding 3 trials. So just go, right? Okay, so it's like, just tell them it's like an hour. So it just takes an hour of their time. Just come up. Okay, but how to really convince them, right, is to tell them that as you guys already know, ACJC chemistry department sucks. It's true. You're died the first year, right? You guys during the first year, so it's a bit hard. Okay, but what you can tell them is that because ACJC chem, right, generally it's never really doing very well. Okay, so it's not very good. Yeah. Like for the past 3 years, I've taught ACJC here. department has never been excellent lah. They've never made any changes. Okay, but the point is, we tell them this first, right? That's why right, they need to come for trial early lah. So the main idea is to tell them to come early because if you don't start early, then you have like some of the problem that you guys are technically facing now, where there's not enough time for this and that, and then you all forget like everything in the first half of the year or last year. So the point is to get them to come early because the chemistry is not good. So you must start early. Anyway, it's a free trial anyway, so you get them to come down first. Yeah. Okay. Then the third thing is, of course, you can tell them more about like the place here or whatever. Like, just tell them the vibe school though. Okay, because I feel that a lot of people, right, when they think of tuition center, they think of teacher, right, they think of a old guy. Because it's quite common, I guess. And just tell them that I'm not old. Right. Okay, then I don't know, this might help. Okay, but don't just like look at them over this, don't just like barrage them with this info. Like prior to all this, right? Perhaps you can like check them out a little bit and ask them how were their O-level grades. Like ask them about O-level grades, then you segue to your 10 grades. And then from there, they segue into all that. Yeah, so I think you all know how to chat out the J1s or whatever. Okay, but the thing is, you can tell them once in real life, but that's not enough. The main source, the main channel is really through texting. If you text them like that, I think it'll be fine. They'll remember one. But the main purpose is, right, if they go and start late, right, then there'll be a problem. It's a cyclical problem where they start late and I can't really help them because they have one whole year of content, right, worth catching up on, which is very difficult. So the purpose this year, why Crucible, right, had this combination is also because we want to make sure that our J1s, we secure them right now. Okay. Yeah, then none of those problems will come in later on. Start from the beginning, so it's the idea is early. Okay, ask them about that first. Of course, if they don't take chem, then don't need to like convince them any further already. So if they take chem, then you can ask them about their grades and whatnot. Yeah, but at the end of the day, right, you'll probably hear two responses. Those that are not very good, and then most of them will be quite decent. And you can tell them that also, right? Actually, I realize a lot of J1s they think that chemistry, right, is like A in JC also. But tell them that it's mostly ES and U, and E is considered good. It is quite cool. E is considered good. You look at your school results last year. The one that you all told me about. Your promos, what was it? I think like majority failed as well, right? Yeah, I think majority of your school failed. So E is considered good. Like what I've told some of you guys also. So this is based on your own experience. I'm not like bullshitting anything also. So it's based on your own experience, which is quite legit. And this one, right, I tell them that it's a must to go already. It's like must.
Tell them that we didn't do well.
No lah, no, y'all didn't do well because you haven't joined yet. Because some of y'all joined me after promos. Most of y'all in fact joined me after promos, or like just at promos. So it's like no point. I start early on. Yeah, and vibes lost, I guess. Yeah, and if all that really they're not very convinced, right? You can still tell them the reason why I say end March, this is easier because they get 50 if they join. If the money somehow okay, we are okay to that. So they will join. If they join, they'll get $50. But this only lasts until end March. So by like before after that, right, you can still put them in. It's quite likely also, but they just won't get the money. And by end March, okay, you guys, you get $100 each, right? Per J1. Of course, you don't tell them this stuff. This is like a hidden one. Okay, so you just know keep in mind also on top of getting $100 each. Yeah, then this one, right, is like you can pay it up for the money because this basically the center's money. So yeah, this is not even just it. I mean, at the end of the day, I'm still treating your high now. So you earn money and you high it out as well. Then if let's say right, you all can continue, we can even set another target. Like if another 15 by the next half of the year, right? Yeah, I thought of a few things now. Yeah, you can tell them this.
Then we go for we need to go stop. We need to go by one J1, right? And then we branch out. No, but after the J1, I think start.
Y'all can like formulate your plan or whatever. Okay, let's just say for Gemma, right? You have people GL, correct? You can think of like 2 or 3 people who you're closer to, and then you just text them, Karen. You don't need to think of like, wow, God, 5 and all that. No, not so many. 1 or 2 close that you're close enough, you're comfortable to talking to them, and just ask them about it. Then check them out, look.
Yeah, I put teacher already. Okay.
Yeah, so remember, it's only when they join, then you all can get a 50. So that one I'll just update you. Like, if we can go above and beyond this target, right? I even thought of like, for other stuff, like I'll give you all my credit cards for like 1 hour, you're going to buy whatever you want and whatever you want and something more, something. I thought of that today in the shower, I was like, hey shit, that sounds like a good plan. That's not possible. No, just after if you all can really hit another like let's say another 15 suddenly. Yeah, then I'll just do that like 1 hour and more, right? 1 hour and more, you all just use my card until yeah, can lah. So, yeah, really, but of course that one it depends on what the next target is. See whether you all can. Right now we try to hit this first. Okay, so that's just a preliminary idea.
They cannot go.
There could be an Apple store, who knows? Anything in that. But now they don't say that, right? Then the target must be higher already. If not, cannot afford. You know, I'll try.
Okay. No, but then when they get report, right, they're not going to say who it is,
Alright, let's come back to the questions. Okay, so guys, you all turn over to question 7. You always take a picture of this first. Question 7 is a very important question. Okay, because I want to go over one thing that might appear in your school tutorial. Okay. Question 7, part A. I want you guys to do one thing first. Draw one chloroethyl benzene. Okay, what is it? One chloroethyl benzene. This, I think someone showed me a similar question in your school tutorial. Draw this first because if you draw it wrong, then the whole question wrong also. Yes, correct. Okay, very important question we're going to do now. Okay, remember when you break down a name, it's always from the right to the left. It was a 2 carbon alkyl chain. Okay, let me look around first. Okay, most of you guys have the structure already. Okay, so come, let's break down. First of all, there's benzene. No shit. Okay, but you have a ethyl group. Okay, this bracket over here, okay, actually doesn't matter in this compound. Later I'll go over another compound. Okay, but anyways, ethyl is 2 carbons, correct? Of course, the ethyl must be of benzene. Agree? Okay, but can you see, right? If they bracket this part over here, that means this right here is the unit they are together. The 1 chloro, is it on the ethyl or is it on the benzene? Ethyl, because it's bracketed, right? It makes sense. Okay, so the ethyl is the chloro is on the ethyl, but which carbon? Because there are 2, right? Is it what is considered first and what's considered the second carbon? Yes, it's on the first carbon. But who is number 1? Is number 1 this guy or 1 on the end?
The one.
Okay, I think most of you guys draw the 1 at the end actually. So this is carbon 1, this is carbon 2.
Oh, why?
Now the reason for that is because you have to understand in these 2 carbons, which one is bonded to a substituent. Carbon 2 is only bonded to hydrogens, correct? Invisible. Carbon 1 is actually bonded to a substituent. So that's why this carbon here has the priority. Does that make sense? Okay, can meaning to say, yes, this is 1 chloroethyl benzene. Now, just to give you guys a bit more information, because I feel like they'll test variations of this. Let me show you guys another 2 more structures. Go and draw this in your notes also. This is the one that I think appeared in your school's tutorial. In these 2 structures, right? In these 2 structures, the bracket actually matters. In this first structure, I can write 1 chloroethyl benzene without the bracket, and it wouldn't matter also. I'll come back to this later. Let's look at the differences between these 2 compounds. First of all, can you draw the one in the middle? I think it's how you all know how to draw. Because I've already gone through this. Okay, draw this first. Okay, so I'm pretty sure you all know what I'm talking about for this second structure. Ethyl benzene, the chloro is on the second carbon. Where's the second carbon? Okay, now it's at the end, same thing, because carbon 1 is the more important carbon that's bonded to something. Carbon 2 is here, which has a chlorine. Got it so far? Okay, but now can you all right, try and wonder, what if you don't have the bracket? How will you change? Okay, it's different lah. Not be the same. But how different is it? Okay, go and try, go and think about it. Okay, don't come out with the same structure. Okay. Yeah, I think you asked me this question later. Let's see if I can remember. Basically, yes, that's why we thought I should be clear. Any idea? No bracket. No bracket. Okay, try to go about this like in a more how the problem solving approach. You notice, right? You ask yourself, what is the purpose of the bracket? Okay, you don't know how to draw this down. Okay, the bracket is to tell you that the chlorine is on the ethyl group, right? That's why they bracketed the whole thing. So now if they don't bracket it, what does that mean? It can't be on the ethyl, it can be only on the benzene. Okay. So that's how you problem solve in this case. What you got? 9. Yes. Okay, so you all can see what we're doing here. By comparing with this, right, we know that it's not on the ethyl, the chlorine actually is on the benzene. So you draw the ethyl benzene first, and the 2-chloro means the chlorine is on the second position, which is the second one relative to this guy. Does that make sense? This is the difference. Why is it that this and this are the same then? Any guesses? You see this one without the benzene? I draw the ethyl first, huh? The 1-chloro is on the what? On the ethyl group or on the benzene ring. Okay, like what we did over there, that chloro is on the benzene, right? But is there such thing as 1-chloro on the benzene? Can I do that here? How? Guys, this guy, ethyl, is already occupying position 1 on the benzene. I can't stick it out here. Carbon already has 4 bonds. There's no way you can do this, although you can't do this. Okay, maybe it's supposed to be. There's a double one. Benzene makes a double one. Okay, so there's no way you can put on the first carbon, correct? So that's why this structure technically, to avoid any confusion, doesn't exist. We are only the only one that is possible is one of the bracket. Does that make sense? Okay, so the reason to that is ethyl occupies position 1 on benzene. So 1-chloro cannot occupy the first position as well. Okay. So there's only 3 variations here. Just for your information.
From 1 to then.
Okay, so this 1, 2, or it can be 1. Oh, good. Okay, now that you've determined this 1-chloroethyl benzene, can you answer the question? They want you to outline a mechanism. Okay, come, outline the mechanism. Okay, go and write the title and whatnot. Okay, everything. Give you a few minutes. Try first. Yeah, ethyl benzene, you go from right to left, right? Benzene is the first thing, then the right is the next thing is ethyl. So ethyl already is first, it's there first. Yeah, of course. Okay, guys, if you don't write SN1, SN2, it will be wrong automatically. Okay, so yeah, you already noticed a few things. This is a secondary halogen alkane. Okay, secondary is the one where you can't assume. So, guys, don't worry. In scenarios like this, the question will tell you something. Look carefully. Okay, so what does that mean?
Equal probability.
Okay, all that, yes. Okay, but we are trying to figure out whether it's SN1 or SN2, right? SN1. Okay. Okay, remember, SN1 is the racemic mixture. SN2 is the inversion of the stereochemistry. Remember all these properties, guys. Okay, that's why this is another question about this. Just now that long ass MCQ question is testing you on whether you know it's primary or tertiary flavor. Correct. Now here's race mate. Okay, guys. So what do you want to do? Highlight the words race mate mixture. Okay, highlight the words race mate mixture, and that is the date giveaway. Race mate mixture is only produced in an SN1 nucleosub. So guys, go and draw your SN1 nucleosub now. No, notes is written.
No.
No, no, no. Okay, never mind. At least it's not tested in the next week test. Good, fine. Okay, guys, there are two steps in SN1. The first step is the what step? Slow or fast?
Slow.
Okay, slow. Okay, the slow step must have how many reagents inside? Okay, one, because SN1, right? Okay, what's the reagent here? Obviously, it has to be this thing. Okay, let me just flip it down here so it's a bit easier. Okay, guys, this is a slow step. You don't show me any nucleophile, not allowed. What happens in this first step? Can you remember? Okay, good. You form the carbocation because the carbon here and the Cl has partial charges each, alright? And then this bond just breaks and then just gives you Cl. Okay, remember this is just SN1 nucleosub. We went through this last lesson. Everything else here follows. Okay. The carbon now has a positive charge. You can Cl minus at the side. Then what now attacks the carbocation? Good. Okay, read the question carefully. It is Cn. Okay, can I ask you where is the lone pair on the nucleophile located at? Okay, carbon. You are bonding to the carbon, so the lone pair must be on the carbon, and it attacks the carbon with the plus charge. Do not attack the plus charge. Bear that in mind. Okay.
Yeah, attack the carbon, right?
It must attack the carbon atom, and you get this. That's pretty much it. SN1 is a very simple mechanism. Now, the second part of part 1 is asking you guys to explain how the race mate mixture is formed. Can you guys try to write the explanation yourself? Okay. Do it point form if you want also. Okay, because I just need to make sure your keywords are roughly there. Your answer down there will be very nice. Yes, sorry. No, you're not even meant to draw it out. It's not even like tested. Okay, you must write out the explanation.
Wait, yeah, is considered. Oh, it's 4 different groups, not 4 elements.
Yeah, 4 different groups.
Yeah. I don't even know. I know, we start with ST3. I realized
No. Before that, it's wrong, not SP3.
Yeah. Oh, yeah.
Yeah, correct. Who is getting 50-50? Yes. All of that. Hey guys, you have to always ask yourself how the racing mixture is formed. Okay, racing mixture means what? Like the pure definition.
It's not.
It contains what?
Equal proportion of
enantiomer. Of two enantiomers, right? Okay, an enantiomer must be chiral, agree? Is this guy chiral like that? Okay, so one example of how they will also ask this question is that this is chiral, but yet it's optically inactive. Why? Because racing mixture and all that. Okay, so you have to start from here. The 50-50 happens here. Attacks from the top or bottom. Okay, so come. The first keyword is The carbocation is trigonoplanar.
Right.
Okay, if it's trigonoplanar, then
Attack from the top and the bottom.
okay, the nucleophile, in this case, go and write the correct nucleophile. Okay, so you attack from top and bottom with equal chance. Eventually, you will form a. Yeah, that's it. So forming a basic mixture. Okay, remember guys, when you study this, when you put it in the cheat sheet, I really want you all to remember the 3 keywords. Because by remembering these 3 keywords, you will know the flow of the explanation. Then you don't need to hard memorize. That's it, yeah. Okay, I'm very interested in the next part of the question. Okay, we've done some argumentative questions last week also. Okay, any questions so far with the first part? I don't think it's hard, the first part. The only important part is identifying whether SN1 or SN2. Okay, I'll look at the next question. Explain why the following mechanism proceeds via the mechanism in part 1. What are they referring to? What mechanism are they referring to? SN1. Okay, so rephrase the question. Explain why this guy undergoes SN1. Okay, you can see that. Let me rephrase now. Explain why that guy undergoes SN1. How do we explain such questions? How do we argue? As when you argue for SN1 or SN2, you need to have a basis argument, right? Yes. Okay, guys, so let's infer. When they print SN1, okay, I know they never print, but they're referring to SN1. They're supposed to argue for the stability of carbocation. If this guy can undergo SN1, it implies that the carbocation is stable. Yeah. So guys, if it's a stable carbocation, okay, I'm going to draw the same carbocation now. It's right there in your mechanism, but let's draw it out. Okay. Right. Here. Okay. I'm going to go into a bit more detail here because I think this is quite necessary. Okay, but can you remember what I actually did this in class? Okay, what is the reason why this is stable? Okay, so let's work backwards. If the carbocation is stable, that means the plus charge is
dispersed to a large
dispersed to a large extent, but because of why? What?
More electron donating alcohol.
There's no there's something more significant than that. Okay, I know there's electron donating alcohol groups here, but no, there's something more significant. The ring. Guys, anytime anything bonded directly to the ring, I want you to talk about the ring. We did this exact question last lesson. Okay, what was it?
Oh, bonded directly.
Now that you are directly bonded to the ring.
Polarized then got.
Oh, whoa. Okay, guys, okay, that's simple here. It's directly bonded to the benzene, so you will have what concept? The localization. You just need localization of electrons. Okay, but how? How does this work? Is it from here delocalized into the ring or the ring delocalized into the?
From there it becomes to the ring.
Okay, no, wrong. Okay, guys, last lesson, come on. Okay, the delocalization follows bridge to poor. Please remember this.
Oh, the ring is
Okay,
big.
so the ring is bridge. If the ring must supply electrons to someone who's poor, right? He must give this guy electrons so that he's not as poor.
Wait, then why just now we say the
Okay.
bromine can be localized into the ring?
No, that's not the bromine. That one's the lone pair. Remember, just now we talked about this, right? Bromine has lone pair. Lone pair is then you can delocalize inside. But this is not rich. This is poor. So you cannot delocalize this into the ring. Okay? Okay, the electrons from the benzene delocalize into the rich, give to the poor. Okay, why can this happen? Before delocalization happens, they must what first? Nope. We went through this just now. For delocalization to happen, it always requires overlapping p orbitals. Write this down also. Delocalization always requires overlapping what? P orbitals. So talk about the p orbitals first. It's not really. Okay, guys, see this up. I'm only interested in this, right? This carbon here has a p orbital, just like the rest of them. This one should also have a p orbital. No, delocalized pi electron cloud is only here. This one D. Yeah, okay, so the p orbitals will overlap first, right? Okay, so then that's your whole explanation, right?
Wait, I don't
Right.
think I see what
What do you mean?
they want. What they talking about? Okay, down then we are.
No. It's 7A part 2. 7A part
Oh my god, she's too tired.
2. No. Okay, guys, take a look. So first you must tell me the p orbital of the positively charged carbon overlaps with the pi electron cloud. You'll be looking at the wrong question. Oh my gosh. Okay, so it overlaps with the pi electron cloud of benzene. Okay, then what next? How redo this explanation one more time.
And then delocalize.
Okay, then delocalize. Okay, from where to where?
From
Okay, so the pi electrons delocalize.
carbon to the benzene.
Okay, good. Okay, no. From the
Oh, the
it
benzene.
delocalize from the benzene to the poor carbon. Like this. Okay, so the first point is your overlapping, second point is delocalized. So that now that a rich person has supplied the poor person with electrons, now what? You mentioned it just now also.
Disperse.
Okay, the positive charge is dispersed to a large extent. Okay, which will do what? Disperse really so.
And then
Okay, what we try to answer.
stable.
Okay, yes, you are trying to say that it's stable, that's how you can undergo SF1. Don't lose track of your goal. Okay, so carbocation ion is stable. Thus undergoing SF1.
I thought I talk about this plus electron.
Oh, you truly are shooting.
Why electrons are you?
Okay, because benzene has high electrons.
They're called pi.
Okay, so just high electrons.
Then just say electrons. I'm confused.
Okay, you must say high electrons, right? Because
They always five.
p orbitals contain high electrons.
Yeah.
Okay, not like sigma electron. Okay, high electron cloud, right? So it's high electron cloud, delocalized and high electron similar. Okay, so that's it.
Wait, so the explanation is different from the last week.
It's the same one actually.
No, but this isn't
No.
right?
In last
It's about
lesson, let's see, it's right here. That is the same exact structure. That's why I gave you guys once last week.
But normally, right?
It's not a normally, it's just an example. No, it's just an example question. Okay, good. Important question, once again, put it in your cheat sheet. This whole thing, like part A. We're not going to do part B. Okay, more questions to try. Okay, whatever you're so happy. The next one might be harder, you never know. Okay, any questions so far? Okay, take some time to understand this, guys.
Well, this is 2 marks.
Yes,
Tell me I'm doing it.
you're not doing it. Right? I mean, we went through this last lesson already. Actually, it's not that bad. Okay, we're going to do question 9. Question 9 is it's a CJC question, no more than.
This is very good.
Okay, yeah, you all do part 1 first because part 1 is very simple.
Why am I then come completely right.
Oh my
I mean, oh my god. They're overdoing it. They need much. They need too much. They need. Yeah.
Okay, yeah, I'm just covering many questions today so that you can do it second round. Yes. You shouldn't take every time because you can't generalize it. There are some compounds, right? There are really science is full of exceptions, right? So you shouldn't generalize. But you should think of it this way instead. Okay?
Wait, SN1.
If you favor SN1, yes. If you undergo SN1, it means you have a stable carbocation. What you said just now is all stable carbocations will undergo SN1. I can't guarantee that. Can you see that? I can't guarantee this way. But I know for sure that anything that undergoes SN1 implies it has a stable carbocation.
Those SN2 then?
Yes, very low stability difference. See the way you ask me the question is really opposite. It must be the other way. Okay. I just told you about. Hydrolysis is just nucleoside. Let's treat it as nucleoside first. Okay, it's everything we've learned so far. Okay, sometimes they will. Okay, this reaction here that you have learned just now, it is a nucleoside reaction, but sometimes they may interchange it with the word hydrolysis for some odd reason. Okay, so this is a nucleoside reaction. Sometimes they may interchange it with hydrolysis. Okay, so I'll just tell you all now first, in case you see it again. They're just referring to this simple reaction that we have learned. Okay. Okay, guys, how do you do part one?
Wait, bromine is larger than Cl.
Yeah, it is.
Yes. Is this
Yeah.
with the orbital overlap?
Yes, correct. Okay, guys, there's just this one page in the notes we talk about rate. And the rate in halogen alkenes, the rate is dependent on what? On strength. That's it, yeah, that's it. And we know bond strength is effectiveness of orbital overlap and all that, right? Yeah, that's your answer. Okay, so style with bromine is larger than chlorine. Since it is larger, CBr has more effective or less effective? Okay, good. Less effective orbital overlap. Okay, so CBr bond is weaker, so hence it's faster to break. Finish. Okay, so sometimes, right, guys. I mean it's good too, but it's 1 mark. Let's just move on. Okay, finish. You have written more than enough for 1 mark.
Yeah.
Okay, so
Now we'll even to.
no, I don't care about the teacher. At the end of the day, A levels is not a teacher mark. Okay. A levels is white people mark. White people are nicer, right? It is like.
Yeah, but I like
It's like when I learned driving last time, right? I always wanted a Malay driving instructor. They're always nice.
Oh, really?
They're very, very nice. Yeah, but then the Chinese old uncle, right? Wow, I hate them, man. Serious. They are grumpy, they'll scold you for not even like press the brake a bit too hard, right? They'll scold you. Last time I was an old Chinese mama. Oh, then my driving exam actually got a Malay instructor. Then he very, very lenient. So great.
We'll go crash the car.
Now what?
Wait, so you right?
Yeah, great. Other car so freaking expensive. Ethan on the other hand, of course.
Yeah, we star.
Only I can afford first. Hey guys, you want to try the synthesis pathway in part 2? Okay, go try it. Guys, after this question, we got one more, alright, chop chop. And the suffering will end. Small W's. Okay, think about the suffering for this lesson. Okay, come, go and try, go and try. Well, if people taking A-level results, chill. People taking the whole thing. Don't take Chinese only, not single. Guys, get the first box at least. The second box cannot get, never mind.
Sorry. Okay, sorry. I have any history, sorry. Not like any.
Okay, guys, before I talk about the cyclic structure, can someone tell me what's the answer for the middle box?
Replace the bromine.
Okay, why didn't you replace chlorine instead? Okay, we already mentioned part 1. I know they never asked you to refer, but you already know bromine is weaker. It's easier to break. Okay, did they heat over here? No, okay, so definitely you're not going to break a stronger bond, right? Okay, so that's how you solve questions like this. Your Cl, Br becomes NH2. Must get this first, guys. Must get this. It's 2 marks, so that means you can get at least 1 mark. The last mark, right, is for those like, if you can get it in an exam, good for you. If you can't, just move on. Okay, but there's actually a way to do this. Okay, come. How do we do this question? You notice, right? Okay, NH3 in ethanol actually requires heating, but then they only use the heating in the next step. If they use heating in the next step, what does it actually do? It breaks what? You see, originally, when you all learn this reaction and condition, is ethanolate NH3 and you heat in a sealed tube. The sealed tube is to contain the ammonia, yes. And you try to find the similarity with that to this. There's ethanolate NH3 without the heat, right? But they only heat later. That means the heat, what's it gonna do? Okay, yes, exactly, guys. Remember, I mentioned that the heat is used to break the bonds. Here, you don't need heat, implying that it breaks the weaker bond. Here, you heat, implying it breaks the stronger CCl bond. Can see that? This is how you solve, right? Now, okay, you break the CCl bond, but then later on, there's a cyclic structure. How, if a cyclic structure is formed, what does this imply? What kind of reaction? No, not step up. Remember, step up must involve nitrile, CN. There's no CN here. Did they add anything new? They only heated the compound. Can you all see that? They only heated the compound. Somehow from there, you can form a different looking structure. Okay, so the Cl broke off, and then somehow a cyclic structure is formed. Okay, so what does this mean? I need you to take this down as well. Usually, right, if no other reagent is added, okay, if no new reagent is added, what kind of reaction do you think is happening here? The word cyclic also points to it. Okay, you don't add any other reagent, so this guy reacts. How? Okay, he can't react with something else, so he can only react with itself. This is an intramolecular reactor. Okay, guys, I repeat.
Oh, I thought you were getting that right.
Okay, that's what I'm telling you all now. Okay, the first time you all see this, no one can get it. Only after you learn. Okay, when you add a different reagent, okay, that means it's an intermolecular reaction. Can see that? This guy reagent A reacts with reagent B. Okay, good luck. Now you don't add anything new, but somehow something happens. It can only react within itself. Can see that from now on. So one clue for intramolecular reaction. The first clue is no new reagents added. Guys, take note of the second clue. Intramolecular, second clue is cyclic. Guys, when you react with yourself, do you agree that you're going to close the structure into a loop, a cyclic structure? But how does this work? Okay, I don't really care about the answer here. What I'm concerned about is how you identify an intra-reaction. First of all, now let's look at the answer. You break the CCl bond. Let's just assume the CCl bond break. Okay, then what's going to happen? The carbon here has now what? Okay, wait, slowly. You break the CCl bond like this, right? And then the carbon here now has a what charge? Plus. Okay, we do that first. Okay. How does it form a cycle? How do you react within yourself? Yeah, pretty much. Guys, who attacks who? Yeah, it becomes a triangle. Who attacks who? N's lone pair, because it's rich, attacks the. That's the answer. Okay, we'll come to that. Okay, I get what you. Okay, what are the questions come from? Okay, so do you get I break the CCl bond first? CCl bond breaks because I. So now I remove the Cl. You see that? So now the carbocation is formed. But somehow, right, I don't have any external reagent already. It has to react within itself. So who reacts with what? React with what? Remember, all organic reactions is always rich attacking poor, right? Your job here is to identify who's the rich and who's the poor, and they'll just react. Who's rich? The N, because he has a lone pair. Who's poor? The carbon. So you look at that. What's this shape, by the way? 1, 2, 3 items looping together will be a triangle. So I need you all to draw a triangle structure. What do you mean? There's only one molecule here, you just react with itself. Okay, that has how many H's?
2.
Okay, currently has 2 H's. Okay, let me just put it there first. Guys, how many bonds does N have over there?
4.
Okay, is that possible?
4.
What do you do? Come, how do you fix this? Very quickly.
Positive.
Okay, remember a final structure shouldn't have a plus or minus charge. Okay, let's just remove my H, right? Yeah, just remove a H.
Wait, so it's bonded to.
Yeah. Okay, so this N is bonded to 2 bonds here and then 1.
So
Not 2 H's. Again, guys, the first time you all see this, which is now, you will be like, what the hell, right? No worries. Okay, what's important here, I don't really care about the structure, I care about this. Okay, how you spot intramolecular reactions. Valence. Nitrogen is 5 valence, right?
5. So then you got 1 to the hydrogen, 1 to the hydrogen, all the way, yeah, right.
And H. 1, 2, 3, 4, 5. Can see that? Any more questions regarding this? I have to go over one final question because this is another question type. You see, a tutorial lessons like this. Okay, you'll be, yes, I know some questions here. Okay, I'll cover as many important question types as you can. You go back, really need to review. If you don't review, you're going to be a lost the next time you come back. Then it defeats the purpose. Yeah, okay. I know you feel overwhelmed now, but the next time you look at it again when you're home, right, it will be better, trust. Okay, it won't be as tough as the first time you see this. Okay, Ken? Okay, now these are level of questions, so I understand how you feel. I've been there also. Okay, so no worries.
Wait, every time you squeeze them together, they will react like what's kind of like anything.
So every time you eat them and you don't eat anything.
Yeah, when you just heat it only, right, then somehow it can turn into something else. Yeah, that means don't need to be. It is unstable, okay, but this is the question lah. You are trying to form this. There's no other choice. Yeah, okay, good. This is unstable because triangles are freaking unstable. Right? One line cannot be lah. No. Triangles are smaller. And guys, I know it's a bit intense on the lesson. Yes, I know I'm moving through exam questions. Yes, these are exam written questions. Okay, but let's look at the last one because we also covered all these reactions in the first lesson. Question 12, not the whole thing. Okay. Question 12, yeah. Look at B, just part 1. Okay, just look at B part 1 first. Because this one, B part 1 will lead to part C, which is what I'm concerned with.
So what is it?
Okay, just do part 1, just do part 1, B part 1.
Four steps. What is the secret? Oh, but the steps are also because the thing. Don't need. Put a right for it.
Okay, guys, how do we turn bromo ethane into that thing over there? Hey guys, can we achieve this in one step? Actually can. Again, my point is not this question, my point is part C and part D. Okay, but we did this for part C and part D. Okay, guys, can you tell me what's the reagents for this? Yes, this one can do straight. Ethanolic, concentrated, and it's free. And you heat in a sealed tube. It's the exact same thing. Okay, again, I'm not really concerned with this. Okay, they want you to draw. Okay, look at part C. They want you to draw the mechanism for this. Okay, go and draw. That's what I'm concerned with. Yes. What?
This is SN2.
Wait, I don't care about the steps yet. You identify SN1 or SN2.
One lah.
Why not you all explain yourself of the draft? Okay, it's not
This conversation, the science is not easy.
It's not easy.
Error easy. Error very came from that person. That person did from that person. That person.
Yeah, it's like everything. It's not just that. Like look at religion. It's some people decided to be oral, some people decided to idolize and worship people, and that's what religion is. It's everything. Yeah, it's just. It's not like actually you're not talking nonsense. It's actually it's a branch of I hate it. You learn uni lah.
Why? Then you go question live, dude.
It's like a concept of doing a preview. I can tell you more about it in my philo class. It's quite interesting.
Oh.
Okay, but you know how the conversation started?
The what?
Should we separate up? Should we follow up?
Guys, imagine if I to ask if you want to join tuition and I think it's better. What the tuition center teaching you? Wow, lah. We are draw to cancel first.
Why?
And two.
Why?
Okay, something like this, and she will not like it. I don't want to hear you first. Yeah, correct. So now I turn.
I think this isn't too bad. Wait, but I'm trying to see how you do.
Yeah,
But I cannot see how you can.
what there you do? What is it about?
Yeah.
What?
I should say why.
One step, right?
No, do you know why?
It was such share, right?
Yes, right. Do you know why? Because it's 1 degree.
Oh.
Thank you.
Yeah,
Yeah, it's primary.
primary school is SN2.
Yes, correct.
Oh, that's a wrong girl.
One SM2 very easy because it's primary Halogen. Okay, that's it. Okay. If the question never mentioned anything else, right? Just use your base assumptions. Okay, primary.
Bruh, I
Nope.
so it's what is the nucleophile? And it's
It's minus
Yeah.
but and it's really hard. It's a difficult one, isn't it?
That's the one that we did.
We know
The
it's
blank
a
piece of paper. One draw on the paper.
Right, we did it before.
Yes.
Okay, I won't see anyone.
No, that wrong.
You must. And you must draw stereotype.
Yeah.
Like this, I give you 3%.
You don't need to study. If not, the tutorial so difficult.
Finish alcohol is good.
Then you follow the entire goal. Then explain to your parents. Your parents will understanding. It's fine. Why not you tell your parents right now? Oh, my teacher might call you, but let me explain. Blah 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 blah. Guys, you can reason your parents. You can't reason it. It's fine. Reason your parents. I feel like they've used this crap since when you were young, right? It's like, oh, call your parents, and then it's the and your parents will prove your ass. No lah.
You're literally 18 and he's threatening to call parents. He's so stupid.
So if you can't immediate a threat, why not you settle the parent part? You get it, right? You reason your parents. Because I know got people, right, got teachers call their parents, then the parents like, these teachers are it's like talking shit because I know my child is not like this. Yeah, you all can do that also. Don't let that trend like you then serious he say, oh, I'm gonna call your parents. Okay, no, call up. Yeah, really, just call up. I mean your parents would have known like this is
Wait, I don't know how to draw the stick man.
You can choose anything to be on the direction.
yes, correct.
No,
The picture is
but
consistent. Hey guys, take a look up. This carbon should be in the middle. Yeah. Okay, let me put H here. Let me put the alkyl group here. Sure.
Oh yeah, same.
Okay.
That's what I do.
So you're just converting it into this stereochemical format. Your nucleophile must attack from where? Is it anywhere?
Okay.
Okay, nucleoside attack must attack this poor carbon. Like this. Remember the lone pair is on N, and then lone pair attacks from behind, attacks the carbon. All good so far?
Yes.
Right? What do you form next? Okay, this is the what?
Transition.
Okay, the transition state. Slow step, you're gonna form the transition state. Dot 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 with the nucleophile and dot 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 with the halogen. The rest, withdraw. That's a solid and dash wedges. What you need to do? Invert them. Okay, invert them like this. Is there a charge on this thing? No, neutral at the start. It will still be neutral. Okay, what's next? Okay, now, yes, you finally get out of the transition state. You will now have the BR. Okay, the BR is gone. And everything is now leaning towards the right hand side. Guys, this is a matter of just doing it again and again until you can get the flow. It really isn't anything new here, right? Is there anything else? Okay, remember this is the difficult one that we did. Okay, what else do I need to draw on the product? There's something missing on the board.
One of the head. There's too many head.
Okay, yeah. Before that, yeah, there's too many H's, yes. Okay.
Plus sign.
But the nitrogen must have the plus sign, yes. Okay. Plus charge on nitrogen. Then you can draw the final compound. Eventually, the NH3 must become NH2. Draw the final compound first if you're still not sure what the arrows are. Okay, remember the swap or the inversion was stereochemistry. HBr. How do the arrows go? Can someone describe? Yeah, but I addressed this last lesson. I know it's a one-step reaction, but this is not part of the closed sub mechanism already. Okay, this is just an adjustment step. Okay, so one of these H's, right, will have his bond gone to the end. Because we're equal. Who takes the H away? Look at the final products. Who ends up eating up the H? The Br minus. Good. Okay, I mean, this is the lone pair. The lone pair must attack the carbon, the hydrogen. Okay, guys, we've done this exact same thing. So really, it's quite pointless for me to go through this. Right? Just repeat this again. Already. Do it like 3 more times, right? You don't have to repeat that again. Okay. Instead of go through part B a bit more time.
Oh yeah,
I mean, you have to show the bonds now. Yeah. Okay, anyone needs to go back like the rush? I mean, tomorrow's Saturday. Anyone in a rush? You in a rush? No, okay, I want to go through part B. Right, okay, so come, I need to go through part B. Okay, I need you all to read through first, see what on earth is trying to say. Okay, I'll erase this mechanism in a bit. Actually, no need, I'll just leave it. Yeah, your improvement in chemistry comes in the tutorial, not in studying content. That's something I can guarantee. Okay. That tutorial is harder. It's not easy to improve. Okay, guys.
Yeah, me too.
Okay, let me, if you can't really understand the question, let's explain part B. Okay. While doing this reaction, guys, come back to this mechanism. While this is happening, you have a product called CAH20. Okay, just go and highlight the whole thing. CAH20 and Br. Okay, so let me describe. While this nucleus sub process was happening, there is a byproduct formed in the process that has so many more carbons, 8 carbons. And this guy here, okay, go and highlight this, gives an immediate precipitate. The word immediate is very important. Immediate PPT with AgNO3. Okay, I talked about AgNO3 earlier. What's the significance and all that? Okay. Come, settle this red color text first. AgNO3 means you're gonna bound to form what? Okay. They say precipitate somehow. What's the precipitate? Good. Okay, guys. You remember the question we did, a very long-winded MCQ. If you form the precipitate immediately, that means what? Ions. Okay, good. So what's the ion in this case? Look at the product. Okay, so the precipitate you're gonna form is AgBr. You form it immediately because this Br over here is an
ion.
Already an ion, yes. Okay, again, these very, very important clues are. So I say again, AgNO3, there's bound to be a silver precipitate, silver halide. Immediate means you don't have to break the Br bond, it's already an ion. So guys, let's break this down even further. If Br is a minus, the rest of this molecule has to have a plus. Okay, so come right here, CAH20 N plus, and then there's a Br minus. I'm interested in drawing this. But the question is how? Yeah, I know they ask you to write equations. No, let's not care about that. I just want you to get this product. How on earth does a 8 carbon molecule even come about when I only started off with 2 carbons? How the hell does it go to 8? So, you remember the one with wings?
Yeah.
That shit, right? How does it go to 8? Can you tell me? 2 first becomes 4, then becomes
8.
Oh.
6.
You're adding 2, you're adding 2. 2. Okay, the specifics we go later, but guys, this question highlight and must put it in your cheat sheet because this is the way they test this particular multi-sub reaction. Okay, multi-sub, okay, of your RX and ammonia, basically. This is the way they test this question. So you must place this in the GG and you must solve the question while doing the GT yourself. Okay, so looking at this, how do we draw? How many wings does this guy have? 4 wings. How big is each wing?
Wait, why are you
Okay, and then 2, 4, 6, 8. 4 wings. Each wing is 2 carbons. 2, 2, 2, 2. Those 8. I went through this concept the other time during the thing. So as you're revising that, please, when you're going through that content, I need you all to paste this question in your cheat sheet also. I repeat, that particular reaction, paste this inside. Okay, so how do you draw this? It's not that hard. Okay, how many wings does the nitrogen have?
4.
Okay, how big is each wing again?
2.
1 wing, 2 wings, 3 wings, 4 wings. That's the structure already. What else? Let's finish it up. Where's the flash chart? On the N, because N has how many bonds?
Supposed to have 3.
Okay, you're supposed to have 3, you have 4 bonds, let's put the flash chart on N, and then let's finish up with the Br minus at the side. This right here, the structure has it. Okay.
Yeah, minus one.
They're ionic bonds, so plus minus.
Will it always be N in this?
Yes. When we look back at the multi-sub reaction, you will see how the relevance. It's just wings, yeah, the Batman one, okay, just wings. Put the N in the middle, then put the correct number of wings in the top. Okay. Usually they test the 4 wing one.
Reason is NH3 is always just this kind of thing.
It doesn't need to go all the way there. It could just stop at the first substitution. Yeah. If the conditions allow for it.
So in this case, the multi-site first, then the exam.
Because they said so also. I mean, they said there's a product, but yeah.
Region.
This one was the confusing one. That one, guys, okay, just go look at it. Everything is explained there. I already explained the other time. Yeah. If you're still unsure after looking at it, then you ask me. Okay, now let's not answer the question 2 times. Okay, go back and look at it. Okay, so that's pretty much it for today. Okay, if you want let me see or whatever the school, your school will be that one. Yeah, okay, you can ask me also. Yes. Yeah, okay, they purposely don't say what. If they say multi-sub, everyone know the answer already.
Yeah.
It's for you to infer from this. Like you see how they ask you, we worked out all the inference together, then immediate precipitate, all that is to point towards this multi-sub. Yeah, it's not that easy, that's why. Okay, you don't ask me any of the school questions, again, please feel free to ask me now. Okay, other than that, yeah, that's it for today.
That's something that we were going to.
That's fine, so it's fine.
This is the thing we were doing just now.
Yeah.
I really answered all the correct.
You're doing the actual question for me.
You know what's the problem?
Okay, all of you all have the same teacher except for both people. So you have the same
I
teacher.
got the I got the resonance stable line.
I have to see the question or I can't read this.
You're so many people are doing it. Resonance